All right, so anything that your denominator is missing, it needs to be multiplied by in order for the LCD to be the same, the denominators to be the same. So now that the denominators are the same, I can actually combine my like terms. I can actually make this one fraction. So that would be x plus 2x minus 10 all over 3 times x minus 5. And that reduces, just combine like terms, so 3x minus times x minus 5. Check to make sure there's no other like GCFs. Like if you could take out 3 from the top, then you would want to do that so you could reduce those 3's, but there's nothing else we can factor or reduce. The second one, we're going to subtract. So subtracting, just please make sure you watch out for the subtraction symbol. Sometimes it helps to just automatically change this to a plus and put the minus in front of the 4. That helps me visually so I do not forget that instead of this being a negative, instead of this being a minus 4, let's make it adding a negative 4, which is the same thing, which will just help me not forget the negative. Because when it's in line with the fraction bars, sometimes it just kind of disappears. Okay, so the LCD, so the denominator here, a plus 2, cannot be factored. There's nothing in common. A minus 3 cannot be factored. So your LCD is, well, they both have the same number of terms, so it's definitely a plus 2. But guess what? A minus 3 is not the exact same as a plus 2. Therefore, we have to put it again. We have to put it here. So a plus 2 times a minus 3 is actually your LCD here. And that's the denominator that you want your fractions, your new fractions, to have. Okay, so you have this denominator right here has an a plus 2. So what is it missing that we need to multiply by? A minus 3. So we have, this should be multiplied by a minus 3 over a minus 3. So on the top here, I have 4 parentheses a minus 3. I can do the distributing now or later. I guess I'll do it later. And then this is plus a negative 4. Okay, this fraction is missing what? A plus 2. So we need to multiply this by a plus 2 over a plus 2, which would be negative 4 times a plus 2. Now we have the same denominator. Go ahead and distribute, okay? Distribute those 4's in, and then combine like terms. 4a minus 12 over a plus 2a minus 3, and then plus negative 4a minus 8 over a plus 2a minus 3. This combines okay, I'm going to combine like terms. I have 4a plus negative 4a is 0. And then I have negative 12 plus negative 8 should be negative 20. You can put the negative in front of the 20 or in front of the entire fraction. But since we only have a number up here and then these are special groupings, there's nothing else that I can reduce. All right, complex fractions. Okay, so the first complex fraction that you have is actually a fraction over a fraction. And if you have a fraction over a fraction, yay, that makes our lives much easier. We actually can rewrite this, okay? So really what's happening is you have the fraction 25 over x plus 2, and then it's dividing the fraction 5 over x plus 5. So I'm going to write them next to each other and change the division to multiplication and flip the second fraction. Okay, that's a lot. So let me go step by step. 25 over x plus 2 is being divided by 5 over x plus 5. That's what this big, tall looking weird fraction means. Then I'm going to change the division to multiplication, because when we divide fractions, we're really just multiplying by the reciprocal. So it's going to be 25 over x plus 2 times x plus 5 over 5. Okay, so I have 25 times x plus 5 over 5 times x plus 2. I just put it in one fraction, but I haven't actually multiplied anything. Yes. So we have 25 over 5 does reduce to be 5 over 1. You can leave your answer factored. I guess they do distribute the 5 back in. But yeah, I would accept either answer. So 5 times x plus 5, and then 1 times x plus 2 is just x plus 2. So this is an acceptable answer, or distributed back in 5x plus 25. That's also an acceptable answer. But why do the extra work if you don't have to, you know? Okay, so we have another complex fraction. It's a little bit different though. We do need to multiply things by the LCD to simplify it. It's not going to be quite the same. When you have a fraction plus a fraction up here, you cannot do that nice little, change the sign to multiplication and flip the fraction, okay? It's not the same. That only works if there's not a plus sign in between. So what we're going to do is we're going to actually find the LCD, and then we're going to multiply everything by the LCD to reduce. And when I say that, I mean we're going to multiply by a special form of the number 1, because that's all we're allowed to do. But yeah, so 6 and x plus 1 and x plus 1. Those are my three miniature denominators, and that's where I'm getting the LCD from. So the bigger part is the x plus 1, so that's definitely in the LCD. But there's also a 6, so group the x plus 1 and multiply it by a 6. Good. So now we're going to multiply this entire fraction by the LCD over the LCD. Now I'm going to write it, since we've got several levels going on here, I'm going to write it as 6 times x plus 1 over 1 over 6 times x plus 1 over 1. Just for us visually speaking, this is the same as 1. My next step is going to be really crowded looking, but then it should clean up a little better from there. So I think I'm going to put it next to it right here. Okay. So imagine we have this fraction is going to be multiplied by the LCD, this fraction, and this fraction. I could be just making it more confusing. Okay. So anything that has multiple things in the denominator, make sure you group it. And let's multiply. The numerator of this first fraction has everything in it, what it already has, and the LCD. So x plus 1 times 6 times x plus 1 over 6 plus 1 times the LCD, so just the LCD, over x plus 1 times 1, which is x plus 1. Over this fraction, 1 over x plus 1 times the LCD, so 1 times the LCD, 6 times x plus 1, over x plus 1 times 1, which is just x plus 1. So 6 over 6 is 1, a special form of the number 1. X plus 1 over x plus 1 is 1. X plus 1 over x plus 1 is 1. So continuing on, I have x plus 1 times x plus 1. I'm still going to write it as a group. Over 1, so I don't need to put it over 1, and then plus 6 times 1, so plus 6. Over 6 times 1, 6. Ooh, can I just cross off the 6's and be done? No, because this is plus 6, not times 6. So go ahead and distribute x plus 1 times x plus 1, and then combine like terms. I know this actually has a special pattern here. X times x is x squared. Then your outside and your inside is 1x plus 1x, so 2x. And then 1 times 1 is 1. Yeah. All right, let's combine those like terms. So I have in the numerator x squared plus 2x plus 7 all over 6. There is nothing we can, we can't factor this. Even if we could, it wouldn't reduce with the 6 because it would need to be a GCF to reduce with just a number. So that is my final answer.